Hello, so this is actually the start of a new unit on trigonometry. So this is chapter 4, section 4.1, and this section will be about angles and angle measure. So one new thing that you'll be introduced to today is something called the radian. So if arc length equals the radius, then the angle of the rotation equals to 1 radian. So this is just another unit of measure. So I'm just going to sketch out here. So if we have a circle, and it's really shaky circle. Actually, will this make, maybe this is a better shaped circle. So if we have a circle, still not the best circle, but, and so from the middle, from the middle to the side is a radius. And if we have some angle here, and that arc length, I'm just gonna color it blue, and if this arc length right here is also the same length as radius, then that angle is what we call a radian. So this part right here, when we're dealing with an arc length that's the same as the radius, that angle that is formed is what we call a radian. So when you think about it, the number of radians in a circle would mean the circumference divided by the radius, because that will be equivalent to how many of these angles exist in a circle. So circumference, if you remember from before, it's equivalent to 2 pi r. That's how you find the circumference of any circle. And the radius is r, so since the r's cancel out, you're left with 2 pi. So in one circle, the number of radians in a circle is 2 pi. Now keep in mind, pi is really just a number. So if you think of pi as 3.14, then basically we have 6.28 radians in a circle. So radian is basically just another way to measure angles. It's just another unit for measuring angles. And from before, we've already used very frequently degree to measure angles, or we're very used to using degree to measure angles. And now we're given a second option. So I'm going to zoom in here. So when we're going from converting back and forth between degree and radian, well, we know a circle is 360 degrees. Actually, probably should add this little symbol here. And the radian in one circle is 2 pi. So I'm just going to add that little symbol there. So now when we're going to, we could think of this as a kind of conversion or using fractions, right? So 360 degrees 2 pi must be equivalent to, well, if it was 180 degrees, which is half of 360, well, if you're thinking of fractions, it must be half of that. So it would just be pi. Now 90, again, compared with 180, is just half of 180, so this must be half of pi. And if we take 2/3 of that, well, that would be pi over 3. And finally, if we think of, again, with fractions, 45, that will be just half of 90. So half of half is a quarter. So 45 is equivalent to pi over 4 radians. Okay, so when this is kind of the equivalency between degrees and radians. Now we're just going to recap a little bit from PreCalc11. So in PreCalc11, just move this here. So in Pre-Calc 11, in chapter 2, we were looking at trigonometry, and there were some terms that we looked at. So first off is we always start here, right? And that start is what we call the initial arm. From there, we always drew some angle, and then we would end up, for example, sometimes in this second quadrant, and we called this the terminal arm. Now, to get from the initial arm to the terminal arm, there is some angle that we may travel, and sometimes you see it kind of represented like such. And this is basically our angle in standard position. So when we're looking at our angles, one thing that you have to be mindful of is depending on the direction you're going, the angle would be represented differently. So if you're going, if you're going counterclockwise, then we're dealing with positive angles, whereas if we're going clockwise, then we're actually going to be dealing with negative angles. And when we're going clockwise or counterclockwise, always start from initial arm. Okay. All right. So let's start getting comfortable with this whole radian business. So we're going to convert the following angles to radians and sketch each angle in standard position. Okay, so to go from degrees to radians, usually I like to use a conversion. So we do know the relationship between degrees and radians. We do know from before, I'm just going to write it here. We do know 360 degrees is 2 pi. So if we kind of simplify that down, we know that 180 equals to pi. So we could just use this relationship here to help us convert from one to the other. So since we're going from degrees to radians, we're going to put that radian option up top and the degree option below. So now the degrees kind of cancel each other out, and we can simplify that down to pi over 3. So we know kind of this is our angle in radians. Another way you might want to look at it is just to look at two fractions that would be equal. So we could think of this as, well, 60 degrees over some radians must equal to the relationship of 100 degrees over pi, right? Which is in radians. And if you do the same math, if you isolate x by itself, you'll have you would have 60 times pi over 180 equals to x, which is what we did above. Now we need to do the next part. So sketch an angle in standard position. So here we have our graph, and 60 degrees or pi over 3 would be somewhere here-ish. Actually, here-ish. Okay. And that is our angle in standard position. Okay. Let's try this next one. So 575 degrees. So again, we'll just do the same thing. So we'll multiply that by pi over 180 degrees. And you should get to something, if you simplify it down, it would be 115 over 36 pi. if you wanted to change this to a decimal, remember you could just treat pi as a number and multiply your fraction by 3.14, and you'll get approximately 10.03 radians as your solution. So 575, or that is going to get you, so from the original arm, we're going to go, it's positive, so we're going to go around counterclockwise once. That's 360. And we'll actually need to go all the way to that third quadrant before we reach that standard position angle. Here's our angle. And the last one here, 250. So we're going to do the same thing, just multiply it by pi over 180. And from here, you should get 25 over 18 pi. Okay, so this is just once you multiply it and then you're simplifying the fraction. And again, for your reference, if you treat pi as a number, you would get to negative 4.36 radians. Now this time, when we have our graph, since it's negative, we're actually going to be going clockwise. So you're going to go around, and we're going to stop somewhere here-ish. Draw the angle in, and here's our angle. So we're going this clockwise direction from the initial arm. Okay, so now that we've gone from degrees to radians, let's just convert angles to degrees. Now, how do you know when it's degree or radians? Well, you need to look for that little, degrees would always have that degree symbol, radians just would not. So to go from radians to degrees, well, we'll just do a very similar to what we did from degrees to radians, but just backwards. So instead of having the radians on top, we're now going to put 180 on top because we want degrees, and the radian, which is pi, on the bottom. So here, when you calculate, you'll get 420 degrees. And for our next example, again, you'll just go with the same thing. From radians to degrees, you'll have 180 on top, pi on the bottom, and that brings you to negative 330 degrees. Okay? All right, next item on the list. So next we're going to look at coterminal angles. So what are these? These are angles in standard position with the same terminal arm. So what does that mean? So first let's find coterminal arms of 135. So again, we have our graph. 135, I'm going to draw the blue. 135 will be somewhere in this second quadrant. Okay, so this is our terminal arm. So remember, we do always have to start from the initial arm, which is the positive kind of x-axis here. So coterminal arms of this. So we still need to find other angles. So to start, we know that this is our 135, but we need to find another angle that will still end up on this line. So how can we get back on this line? Well, you'll have to go a full circle around. So I'm going to just start with this green. So one way is to hit the line and go around again. That will cut it. So for this one, it will be 135 plus 360. And that is 495. Oops, 495. So that will bring you to the same place. Something else you may do is you might want to go the other way. So you might actually want to go this way and get back on there. And remember, when you go negative, you're actually dealing with, when you're going clockwise, you're actually looking at negative. So that would be just think of it as 135 minus 360, because from your terminal arm, and that would be negative 225. And if you want, you can also just start from the initial arm, hit 135, and then go around, not once, but twice. So that would be 135 plus 720. And that would bring you up to 855 degrees. So all of these angles, even though you're going around possibly more than once, but you will eventually still end up stopping at that same terminal arm. All right, so let's find coterminal angles of 50 degrees where we're looking at kind of the between negative 700 degrees to positive 720 degrees. So I'm just going to start by drawing a sketch, but this is really just to visualize it a little better. So 50 degrees would be somewhere here in this first quadrant, and we're going to be looking in between a certain kind of range here. So I'm just going to draw out some arrows. So we know that coterminal of 50, so we'll have to pass 50 and then maybe go a full circle. That is an option. Or maybe starting from the initial arm and going in the opposite direction, maybe twice, kind of thing, etc. So let's just look at this. So to go around and always end up on that same terminal arm, you'll just add and subtract 360. So some examples might be, well, if we start at 50 and we just add 360 to it, we'll be at 410. If we subtract 360, we would end at negative 310. Now, if we go more than once, maybe we'll go in the negative direction more than once, then we're at 670. And if we go in the positive direction twice around, then you are at 770. Now let's look at our different angles here. So again, we want to stay in between negative 720 degrees to 720 degrees. So these would do, but this fourth angle here is it's out of the running. So therefore, we only have the options of 410, negative 310, and negative 670. If you go one more circle around, you're just out of kind of our restrictions here. All right, next we're going to look at coterminals of this angle here, which is negative 4 pi over 3. As we can see, since there's no degree symbol, so we're looking at radians here. So again, let's just start with a sketch. So in radians, it's going to be a little different. So here is 0. Now recap with radians. This part up here is usually 90, right? At this top part, this is usually 90. In radians, it's pi over 2. 180 is pi. Oops. And then down here is 3 pi over 2. And then off to the side is 2 pi. Now, if we're starting in the initial arm going in the negative direction, at the bottom here, you could also think of this as negative 90, which can also be negative pi over 2. That is an option. And then on the side here is also equivalent to negative 180. And then on the top, it's basically negative 3 pi over 2. So depending on which direction you're going, these sides basically represent different angles. So since we're looking at negative 4 pi over 3, that means we're actually looking at somewhere in this second quadrant because it's over pi. So in this particular case, again, we're just going to have to add an angle which will bring us all the way around. Now, since we're looking at radians, we're no longer going to add and subtract 360. Well, we'll need to think of the 360 equivalent in radians, which is 2 pi. So from our angle, we're going to add 2 pi, and that would actually bring us to 2 pi over 3. Now we're going to just do another one, which is 4 pi over 3 minus 2 pi, which will be negative 10 pi over 3. And there's also negative 4 pi over 3. And we're actually going to go 2 times in the positive direction around. So we're going to actually add 4 pi, go twice around, and it's 8 pi over 3. So at this point, if we still, if we add or subtract another 2 pi to any of these angles, then we're kind of out of the restriction that we want. So therefore, our final answers only include 8 pi over 3, 2 pi over 3, and negative 10 pi over 3. Oops. Okay. All right, so just to summarize coterminal angles, so what we've noticed is, well, what you should have noticed is whenever you're going from your standard position angle, you're going to add, from that angle, you're going to add 360 degrees. You always want to go around, all the way around back to the same spot. And you're going to multiply, or you're going to add that 360 by however many times you want to go around. We'll just call that n. Okay? And n, in this particular case, since you need to go a whole time around, could possibly be any integer. So you could go in the positive or negative direction as long as you're going the full cycle around. Now, if we're not talking about degrees and need to talk about radians, instead of 360, you will be going 2 pi around. And again, n will be some integer, so you can go full way around in either either in the positive direction or the negative direction. All right, last thing here. Arc length. What the heck is that? Okay, so when we have a circle, let me just move it right there. Yeah. So when we have a circle, again in the middle, and we have some radius. Oh my goodness, that's not a straight line. We have some radius. We have some angle. And that would create some length on this side there. That distance on the circle is what we call the arc length. And to find that, there is a formula, which is A, which is the arc length, as we show in the picture, equals to some angle times r. And this some angle must be radians. Okay, so this is the kind of formula here for going from radius to arc length. So let's do some examples. So determine the arc length if r is 4 cm and the angle is 5 radians. So I'm just going to write the formula here because I've already rolled it off the page. So we have r, we have the angle, and we can easily find a. So that will be a equals to 4 times 5, which is 20. So that was quick. All right, next one. This time the radius is 9 millimeters, and the angle is 70 degrees. Again, remember it's A equals to theta r. So we do have some angle, and we do have some radius, but keep in mind this is not in radians, so we will need to change to radians. Okay, so therefore 70, so we could have 70 times pi over 180 is equal to 7 over 18 pi. So now that we have our radians, then we could just put it back into our formula. 7/18 pi. Our radius is 9. And when you calculate this, it's 7 over 2 pi millimeters. If you want to change it to a decimal, remember pi is just a number, so you just multiply that in, and you should get 10.99 millimeters. Okay, so from today, the main thing is just to start to get used to radians because you will be using that a lot in the future. And that's it for this section.